Okay. So let us start with the first question. So we need to find the grammatical error in the sentence. If there is no error, the answer will be D. So the students were awaiting for the arrival of the chief guest. The main grammatical error is here. Awaiting is nothing but awaiting is nothing but yeah, 1 minute. Awaiting is nothing but waiting for. So you don't need for in the statement. So answer is B. So choose the word which is exact opposite of the given word. Flagitious. So what is the word which is opposite to flagitious? Everyone please answer. Please answer. See, we are writing it like an exam. So please answer the questions and flagitious is nothing but having criminal thoughts. So vapid, ignorant, frivolous, these are not directly related. The exact word is innocent. Either having a criminal thought or innocent. So opposite is innocent. Find the correctly spelled word among this. Yeah. Please find the correct word. So it is EMBARRASS. It's not this or this. Okay. What percentage of numbers from 1 to 70 have 1 or 9 in the units digit? So can anyone answer this? Please answer it in the chat once you have finished it. Accept it. Yeah, let us please continue. So what is the percentage of numbers from 1 to 70 have 1 or 9 in the units digit? Let's count as normal digit because this is a smaller number itself. So you have 0, 01, 09, 11, 19, 21, 29, 31, 39, 41, 49, 51, 59, 61, 69. So how many numbers are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So there are 14 numbers out of 70. So what is the percentage? So it is nothing but 20 percentage, right? So answer is 20. Please do this question. Yeah, very good. So let us answer the next question. So the expression of 11.98 into 11.98 plus 11.98 xx plus 0.02 into 0.02. Here this x represents a number. Okay. This x so into something. So how will it be a perfect square? Initially it is given as 11.98 square plus 11.98x plus 0.02 square. If you see this, this is like a square plus b square. So what do you need in between? 2ab. So already you have 11.98 as a. So you can take 2b as x. But b is 0.02. So 2 is equal to, sorry. So x is equal to 2 into 0.02, which is 0.04. Your answer is C. Please do this question. Done. So what is the answer? Why is the answers not popping? 33. Yeah. What is 33? Okay, answer is 33 as well. Let it pop here. Okay. So there are two numbers, 3 is to 5. So you have 3x and 5x. That being subtract with 9. Okay. So it is 5x minus 9 equal to 12 by 23. So what do you have? You can solve it. So 23 into 3x minus 9 equal to 12 into 5x minus 9. So what do you get here? 23 into 3 which is 69x minus 23 into 9 is equal to 60x minus 12 into 9. So you get 12, 23, it is 11 into 9 is equal to 9x. X is 11. So what do you get? The smallest number is 33. 33 and 55 are the numbers, so you get smallest number as 33. Please do this question. This is a very good question, but very easy question also. Right? Did anyone did it? 4. Very good. Let us start it. So you have this angle theta. This theta is equal to this theta. So you can take this cos theta, which is um, adjacent by hypotenuse. So it is PQ by L. Then this cos theta is what? Adjacent by hypotenuse, which is PN by PS. Right? PN by PS. It's given square of side 2s. So PS, you can take PQ. I'll write PL, sorry. This is PL. So I know PL is equal to 2 by cos theta, PN PS. So the side MN of the rectangle passes through side square. So this is a rectangle of square PL PM. Okay, PL PN. So you get a rectangle. So PN is equal to, what is this PS? PS is 2 again, 2 cos theta. Right? So what is the area of rectangle? It is PL into PN, which is equal to 2 by cos theta into 2 cos theta, which is 4. That's all. The answer is 4. So candid is to indirect, as honest is to dash. So what does it mean? Please do this question. So candid and indirect are opposite to each other, right? Candid and indirect are opposite to each other. So honest is indirect to untruthful, right? Yeah, please do this question. So what is it given here? Did anyone answer this? Did anyone got the answer? D. Let us check the answer, whether it is D or no. So it is given as image and field, FIELD. FHBNJ is given as EMFJG. You see clearly, EDIFIELD, okay, image is given as this. How are they related to each other? CHI. Oh, I is related to. Oh, sorry. I have changed the sequence. So the relation is FIELD, and this is what FHBNJ. The IJ, EF, MN, HG, AB are related. So you are adding one in opposite directions. So this is also FG, ED, LM, IJ, GF, right? So it is given as beach, BACH. So you add in opposite direction, C, I. There is only one option directly. So it is B. Understood, everyone? Oh, there are two options. I see. So E will be F here. So with F, there is only one option. Right? Okay. Yeah, please do this question. So whenever this type of questions are given, they have given arbitrary prime numbers. So you can take any prime numbers, especially if both are different. I mean, different means one even, one odd, it will be better because except 2, every other prime number will be odd. Only 2 is an even prime number. So now if you take 2 into 3, is it a prime number? First we'll check with 2 plus 3. Prime number, it worked. 2 into 3, 6. It's not a prime number. 2 plus 3 plus 1 is 6. Is a prime number, is saying. This is also this. Right? Then P1, P2, 2 into 3 plus 1. 7. 7 is a prime number. Is saying P1 plus P2 plus 1 is a prime number. Is it true? 2 plus 3 plus 1 is a prime number. No. So, is not a prime number is wrong. P1 plus P2 plus 1 is a prime number. We got this as a prime number. Then we need to check for other values also. Because everything should work for this. So P1, P2 is not a prime number is true. Then P1, P2 plus 1 is a prime number. Maybe option might have given wrong, but you can take 3 plus 3 into 5 plus 1, 16. So this is not working for this. Is a prime number is not, right? This is also wrong. This is also wrong. So overall you have P1, P2 is a prime number. Is not a prime number is a correct step. Right? Yeah. Please do this one. Right, did anyone do it? Hmm. Okay, let us do this. So AX equal to B is an inconsistent system of equations. So is saying AX equal to B is inconsistent means there is no solution, right? Highest possible rank of A. For a rank, you'll be seeing minimum of these two. When it is inconsistent, definitely it is less than 3. So rank of A is less than or equal to minimum of 3 comma 4, which is order of the matrix, right? 3 by 4 m by n cross n matrix. So which is smallest of this will be that. But when it is given as inconsistent, so you have less than 3, which is 2. Now someone will ask why can't it be 1? He is asking highest possible rank of A. So it will be 2. Okay.
So can you repeat the previous question, please?
Yeah. When A is 3 cross 4 real matrix, suppose you have a matrix which is m cross n. So how do you identify the rank of a matrix is the minimum of these two. Minimum of m n. Rank of A. Okay, you'll write less than or equal to minimum of m cross n. He's saying inconsistent, no. So inconsistent means definitely it will be less than these values because inconsistent means you'll have one row as 0, 0, 0 or one column as 0, 0, 0. That is how you will get 0 solutions, right? Now minimum of these two is 3. So your rank of A should be less than or equal to 3 when it is inconsistent. Okay. So now inconsistent and less than 3 means rank will be either 1 or 2. He is asking highest possible rank of A. Between these two, highest possible rank is 2. Understood?
Yes, sir.
Okay. Okay, let us solve this. It's given as particle of 1 diameter, 1 mm dia. So D is 1 mm. You have density of the particle as 2500 kg per meter cube. Is settling in a stagnant fluid Stokes residue. Calculate the viscosity of the fluid. If fluid density is given, particle density, you can write body. Fluid density, you can write like this. It is 1000. So generally it is kept in water. The particle falls with terminal velocity V is equal to 2 millimeter per second. So buoyancy force will balance this. So body is falling like this against gravity. Buoyancy force will act like this, right? So this particle you'll be considering how much is the fluid, which is what is the volume of fluid which is displacing this. So you'll have 6 pi neta RV is equal to 4 pi by 3 R cube into rho of body minus rho of fluid. So this is the force balance which you'll have. Okay, buoyancy force, right? And this one. Now you have terminal velocity. You just calculate this. You'll get pi will get cancelled. You will get V is equal to 2 by 9 R square delta rho, G is there, into G by eta. So you want viscosity to calculate, right? So you put viscosity here and velocity here. Eta is equal to 2 by 9 into R. D is given as this. So 0.5 into 10 power minus 3 square into density difference is 1500 into 10 you can take G. Then you have nu as what? 2 into 10 power minus 3. So what do you get here? Is 2 by 9 into 0.25 into 10 power minus 3 into 10 power minus 3 into 1500 into 10 by 2 into 10 power minus 3. So minus 3 got cancelled. 2 and 2 got cancelled. So you have 9, 10 power minus 3 you can take as 3 by 2. 3 by 2, 3. So this is 0.25 into 0.25 by 2 actually. So it is 0.25 is 1 by 4 into 1 by 6 into 10. So it is generally 10 by 24. One by 24 is nearly 0.4. So it is 0.04. So it is into 10, you'll get 0.4. So your answer will be 0.41. Units are Pascal second. Okay. Please be careful with the units. They can give poise also. Then the internal energy of an ideal gas. So internal energy of an ideal gas depends on what? Yeah. Please answer this in the chat. B and C. So internal energy, we'll see small differences of this. Internal energy is nothing but heat transfer which is occurring. Internal energy is nothing but heat transfer only, the form of heat energy which is being transferred, which occurs at constant volume. Then what is enthalpy? The same heat transfer or heat energy transfer, heat absorbed or released, which occurs at constant pressure. So Q is heat transfer which occurs due to difference in temperature. You need to understand these three differences. So delta U and delta H definitely depends on temperature. It only depends on temperature if you mean. If you'll ask me, it depends on only temperature. So it increases with increase in temperature. It is dependent on temperature, not with pressure. Okay. Please try this. Very good. You have true stress equal to engineering stress into 1 plus E. So 1000 into 1 plus, what is this engineering strength? 0.1 by 100. So it is 1000 into 1 plus 0.001. So it is 1001. Very good. Which point on the stress strain curve occurs after proportionality limit? So when you take a stress strain curve, when you draw a stress strain curve, you will have point like this and a small point like this. After this, you will be having a anyhow, like you can take anything. It can be generally like this, or it can be like this. Okay. This is for low carbon steel, total atmosphere. Now, this point, if you see, there is some points where you need to distinguish. Till here, sigma is directly proportional to strain. This is sigma E, directly proportional to strain. So this is called proportionality limit. After this, whatever point you get is called elastic limit. And if you draw a straight line like this, at 0.2% strain, 0.2% strain, if you draw a line exactly slope, exactly which is having slope of this line, then you will meet a point which is called as yield point. So this point is proportionality limit, this point is elastic limit, this point is yield point. Then this is strain hardening point. So the point which occurs is after this is elastic limit. Okay. The electrodes used in spot welding are made up of which of the following material? So you need very high temperature it needs to take high amount of electrical energy and it need to have high K. So copper is correct, copper and tungsten is correct, copper and chromium is correct, copper and aluminum you won't be taking generally. Okay. So it's spot welding, right? Very small spot will be there. You need a very small joint like this. Very small. Suppose if I have a wire like this I want to join. Generally, thermocouples are joined like this. Thermocouple, what you have is you have two wires like this. K-type thermocouple. So many thermocouples are there. No? They are very high temperature thermocouples, right? For spot welding, you have two different wires, two different terminals you'll be having. These two terminals will give you difference in voltage. This voltage will tell you what is the temperature difference. So for this, what you'll do is you'll stick them together like this. This is spot welded actually. You'll have an equipment like this. Very small equipment you'll have. Spot welding machine. Inside this you'll keep it. So they both will be joined together like a dot. Okay. How your circuit boards will be inside your mobile phone or laptop, like that it will be welded. So these two will act. So you can't use aluminum for it. Which are the following materials would creep significantly at 50 degrees centigrade? So can you explain how to pick questions, order strategy instead of solving line by line question? Now let us see line by line questions because you need to learn everything. Then order strategy will pick it up. So there is nothing in order strategy. Whatever you feel easy. Suppose you feel easy in physical chemistry. Physical metallurgy. So you start with physical metallurgy. Try to solve all physical metallurgy questions. Or if you are low in confidence, try to solve all 1 mark questions first, quickly. Not to solve every 1 mark question. I'm saying like solve how many 1 mark questions as possible. That will save your time actually. And do aptitude questions if you are confident enough. Once you are, suppose an example, it might not be an ideal strategy for everyone. Suppose if you are able to do aptitude quickly, sir, aptitude will be for 15 marks. So if you are able to do 15 marks correctly, max questions also, if you are able to get at least 10 marks, do all 1 mark questions, at least out of 25 1 mark questions, do at least 15. So you are secured with 40 marks. Mostly you will be in safe zone. Now you go in this 1 hour, you complete this 40 marks. Now spend your remaining time on your 2 mark questions. That might be an ideal strategy. But if you are not very confident enough, start with, suppose in aptitude itself, you see, first 3 questions you are not able to solve. Then quickly change to metallurgy questions. Take those metallurgy questions, solve all physical metallurgy questions. Generally, it will be easy. Then try to solve mechanical metallurgy if you are able to. Try to do matching questions, match the following questions from extract to metallurgy. They will be easy. Okay, then try to do questions, mostly 1 mark questions, try to complete them. Then you see, have a glance in 2 mark questions. 2 mark questions, whether matching you are able to do it, whether any simple question they have asked, which you are able to do it. These things, if you are able to do it, then come back to the questions again in an order. Generally, strategy changes for everyone. So if you are confident in any subject, start with that. Then go for 1 mark aptitude, then solve 2 mark questions. At least keep 2 hours of time. 1.5 hours should be ideal for 2 mark questions. Then half an hour you can recheck your questions again. Okay. Okay. Now let's come back to this point again. So we get creep generally happens in the temperature of 0.4 to 0.6 Tm. Generally greater than or equal to. So let us calculate T by Tm values. So my T temperature is given as 50 degrees. 50 degrees is what? 273 plus 50. How much? 323. So it is 223 Kelvin. A, B, C, D. Let us see. Let us take minimum value only 0.022. 660 plus 273. It is nearly 660, no? 3. 6 threes. So it is 933. 933. This is definitely not, because half of this itself is 450. So this is definitely not. Next one is what? 420 plus 273. You have 673. Nearly you can take 700. So 0.4 into 780 280, which is greater than 323. So this can be the answer. Next, magnesium 650. This is again nearly 930. It is not half, because 360 you'll get 900 into 0.4 itself is 360. So C is definitely not the answer. None of them is not the answer. You can go to option B. See, even though we are doing it slowly, we have completed nearly 18 questions till now. So you are like 15 plus 7, 22 marks are already done. Mostly paper can be solved within 2 hours, even if you do it slowly. I mean, no need to answer all the 65 questions. The number of members in the family of 1 to 1 in a cubic crystal are. So it can be 112, 121, or 211. How many ways you can have? So you'll have 3 factorial by 2. How do we get it? 3 factorial by 2. Next is what? We'll go individually. 1 bar 2 1, 1 2 bar 1, 1 bar 1 bar 2, 1 bar 1 2 bar, 1 bar 1 bar 2 bar. So this will be again 3 bar by 2 bar, common numbers. This is 3 factorial. 3 are different numbers. This is again 3 factorial by 2. This is again 3 factorial by 2. This is 3 factorial again. So 6, this is 3. 3, 3, 3, 9, 3, 12. 12 plus 6 plus 6. 12 plus 12, you get 24. So there are 24 family of members in 1 to 1 cubic crystal. Yeah, please do this question. So you have, yeah, du is equal to first law. This is nothing but first law. dq plus dw is equal to, sorry, dq is equal to du plus dw. dw is pdv. So you get tds minus pdv is equal to du. This is correct. dh, you know, u plus pv. So you'll write d of. So you write du plus pdv plus vdp. So again you get TDS minus PDV plus PDV plus VDP. These two will get cancelled. You get TDS plus VDP. This is also correct. G is equal to H minus TS. So you get DG is equal to DH minus TDS minus SDT. So you have TDS gets cancelled. You get minus SDT plus VDP. Minus SD plus VDP. All are correct. So extensive or complete solid solubility is possible in. It's a very good question. It's a good question actually. Please do this. So it is substitutional solid solution only. Because in interstitial solid solution, you won't be having complete solid solubility. Only in substitutional solid solutions, you'll be having example copper, nickel. These are substitutional solid solutions. Okay. Interstitial, suppose even if I had interstitials, it won't be completely soluble in each other. Interstitials are the one which will occupy interstitial sites, right? Substitutions, isomorphous systems, they can be completely soluble with each other. Okay. So what is the slip plane in HCP crystals? So it is A, right? So what is this diagram? Which one of the following allowances given to the pattern? Please give it in the chart. What is this called? Anyone? This is called draft allowance. Okay. Shrinkage allowances, like you'll be adding extra material counting into the value of shrinkage. Draft allowance is like you need some space for it to shake it and take it out. Right? Shake means I doesn't mean shake allowance. It means the mold should not be broken. It should be removed easily such a way. It should not stick to the casting material. So you need to have some draft, some angle should be there, some draft should be there. That is how you remove the casting easily from the mold. Next one. Which of the physical, which of the which of the properties that are altered through heat treatment? What can be altered through the heat treatment? So all mechanical properties can be altered through heat treatment. Physical properties, microstructure, everything can be altered through heat treatment, right? Annealing, crystal, your grain structure will grow. Properties will change. Mechanical properties will improve, right? Ductility will improve. These all things will happen, right? Strength will decrease at expense of ductility. Physical properties also changes. Material becomes softer. Right. Do this. So what is trace? Trace is nothing but trace of a matrix is nothing but sum of all diagonal elements, right? So trace of AB is equal to trace of BA. You can check with any other thing. Suppose if it is given n by n matrix, you need to see whether matrix multiplication is possible or not. AB multiplication will be possible if this order and this order will be same. BA will be same if you just put it like this, n cross m and A m cross n. So this and this should be same for multiplication. C n cross n, all are same. So trace of AB will be equal to trace of BA if these multiplications are possible. So both the statements are correct. You can try with examples also. Take some matrices like 1 by 2 matrix or 2 by 1 matrix or 2 by 2 matrix and 3 by 3 matrix. Then you try it. Okay. Please do this question. Yeah. So what is the answer? Heat transfer coefficient over surface of 0.5. Did anyone solve it? 1500. Very good. So let us solve it together. So you have Q is equal to HA into, and you also have, so what is this? You need heat transfer coefficient. It is already there. Area 0.5. Temperature 160, 120. So it is 120 degrees centigrade. So it is 1500 watts. Please solve this. I'll tell you one thing here. See, phase diagrams can predict phases present at equilibrium, composition of the phases present at equilibrium, relative amount of phases present at equilibrium. General answer when you study your BTech will be A, B, C. Oh, sorry, A, B, D. But actual answer is A, B, C, D. Okay. Even metastable phases also can be predicted with the help of phase diagrams. Then my question to you is, why martensite is not present in iron carbon diagram, phase diagram? Because martensite is a metastable product. Then why martensite is not present in iron carbon phase diagram? Can anyone answer this? If anyone is able to unmute and answer also, they can answer. Try to tell this. So now,
Hello.
phase diagram will tell you, it's also called as equilibrium diagram. So all the phases which comes with equilibrium cooling, you will be understanding through the phase diagram. So even if metastable products are formed by equilibrium cooling, so then you can say that they can be predicted with the help of phase diagram. But martensite is not equilibrium cooling, it is rapid cooling. That is why it is not present in iron carbon phase diagram. Understood? So that is why metastable phases are not present. According to BTech, only metastable phases mostly you'll be learning is martensite. That is why it won't be present. Aluminium alloys, copper alloys, few of them are there where you can predict. Okay.
Sir.
Sorry?
Sir, I have a doubt, sir.
Okay. So what is the difference? Try this question.
So for the previous answer, ABC or ABCD are correct only. Now.
Yeah. As of now, it is only ABD correct. Because in your BTech, you won't be learning much of aluminum, copper, alloys, everything, which includes metastable phases. Only metastable phases which is included in is iron carbon phase diagram, and you learn about only martensite. So according to that BTech syllabus, your metastable phases are present. Phase diagram can't predict it. Okay, but actually in reality, even those with equilibrium cooling, you can predict it. Okay, so answer is only ABD as of now. If you do any like PhD or anything, then you need to understand this point also.
Sir, you are not audible.
I'm not explaining anything actually. I'm just writing statements. Strain hardening, also called as work hardening, right? Or cold working. So more cold working will happen when it is at lower temperatures. So simultaneous recovery takes place with deformation at high temperature. That is nothing but hot working. Metal is heated above recrystallization temperature. That is nothing but hot working. So A and C is the answer. More strength, more elastic bonding, higher modulus of elasticity means strength of bond should be higher. Okay, that is why you'll see steel is more elastic than rubber. Okay, you'll say elasticity of steel is more than rubber because The bond strength between steel is bond won't break. They can get formed again up till some extent. That is what you call as yield point. Before that point also you have, before elastic limit, these bonds will be stretched and can come back again. In silicon, it has covalent bonding, especially you'll see in these type of bondings. Aluminium will deform very easily than compared to your silicon. The ratio of conduction resistance to heat flow, L by K, and convection resistance heat flow. What is this called? Very good. That is called as Biot number. So Biot number is nothing but conduction resistance by convection resistance. So this is nothing but Biot number. HL by K. This is your Biot number. So find f dash x and put the values in such a way. Suppose you have x square minus this. So your f dash x is 2x minus cos x. You need to see values such a way. Your f of 0, f dash 0 is less than f dash of 1. No, in this function, if I take this as y, your y of 0 is less than y of 1. It means the curve is decreasing. If y of 1 is greater than y of 0, it means the curve is increasing. Okay. Now let us see for y of 0. Y of 0 is nothing but minus 1. Y of 1 is what? 2 minus cos 1. Cos 1 is cos 50. This is positive. So it is increasing. Root x plus, he is asking everywhere. Everywhere, can this be 0? Let us see. 2x equal to cos x. Yes, there can be a 0 value because cos x curve will be like this. The point of intersection of these two will be, there will be a point of intersection between 2x and x. So this is not increasing everywhere. One value is positive, one value is negative, and between somewhere you have 0. So curve will move like this and like this. So 2 is also not increasing everywhere, 1 is not increasing everywhere, 3, only 3 is increasing everywhere. The answer is A. Let us do this. So you have tau is equal to GV by L. 4 into 10 power 10 into 2 power 5 into. So it is 0.1. 10 into 10. So you get 10 power 10. C. The answer is powder metallurgy. See, even with sand casting also, you can make, you can't say complex shapes, but bulk manufacturing or bulk casting will be done with sand casting. These shapes, suppose this bigger shapes you have. These are equipment bases, sheets, everything can be made with the help of sand casting. But this won't be this much intricate. Suppose you have this shape. This is easy to produce. But suppose if you have a shape like this, okay, these shapes can be produced, these intricate shape, not like this, actually doesn't be like this. So I mean a compound which is some flanges or anything, some intricate shapes. These type of things can be produced only with the help of powder metallurgy. Because you'll have a die of that shape, you'll fix powder with this and you'll press it like this. Okay, you'll have shape here, you'll fill powder with this and you'll press it with this, it get compacted and then you heat it up. So this is how powder metallurgy works. Next, the generic name of this microstructure. So it is lamellar structure, lamellar microstructure. Okay, please do this question. So let us see the free settling ratio. Let us see this. There are two things here you need to see in free settling ratios. The free settling ratios, you can write it as rho minus rho naught by um, means rho of a heavy particle. How do you define this? Is suppose you have rho 1 minus rho naught by rho 2 minus rho naught whole power m. When m is 0.5, it is Newton law. When m is 1, it is in Stokes regime. Okay, these two has some basic difference. So you'll be using, you have free settling ratio of quartz. Suppose for quartz, right, of galena. So you have 2.6 minus 1 by what is this? 7.5 minus 1 whole power 0.5. So it is 1.6 by 6.5 whole power 0.5. So 1.6 is nearly 1 by 4. 16 fours are 64, right? 1 by 4 whole power 0.5 is nearly 0.5. So you get answer nearly 0.5. If it is Stokes regime, then you will have 0.25. This is Newton. So let us do this question. So maximum allowable stress for silicon carbide with an internal crack of 20. So maximum allowable stress for silicon carbide plate with an internal crack length of this. So you have an internal crack length. Internal crack length is 2C is equal to 20 micrometers. So you know sigma C is nothing but 2 gamma 2 gamma E by pi C, right? So you have 2 into 2.18 into E is what? 450 into 10 power 9 by pi into 10 into 10 power minus 6 meters. So it is overall 250 MPa. For the same diffusion, the depth of diffusion penetration at 800 Kelvin and 1100 Kelvin is 1:6. Find out the activation energy for the diffusion. So it is given depth of diffusion is nothing but x by 2 root dt is constant, right? So x1 by x2 whole square equal to d1 t1 by d2 t2. Here, for the same diffusion time, the time is same. Diffusion coefficient also will be same. You have exponential minus q by rt1 by exponential minus q by rt2. So you have x1 by x2 ratios 1 by 6 whole square equal to exponential minus q by r into 1 by t1 minus 1 by t2 is 1 by 800 Kelvin minus 1 by 1100 Kelvin. So what will be this? Ln, so it is 2 ln 1 by 6 equal to minus q by, you can write r as 25 by 3 into 1 by 100 into 1 by 8 minus 1 by 11. Minus minus will get cancelled. What is the value you will get? Q is equal to, please calculate. So you have, how do you get this relation is, you know ERF equal to ERF minus x by 2 root dt is equal to C Cx minus Cs by C naught minus Cx, right? In this, what you'll take is this to be constant with respect to your diffusions. So you'll get x by 2 root dt is constant. Generally, this is taken as constant. So overall, you get x by 2 root dt is constant means you'll get relation x is proportional to root dt. So x1 by x2 whole square is d1 by d2. Your d is nothing but diffusion with respect to q by r at temperature with respect to Kelvin, and q will be in kilojoule per mole generally. Okay, this is the relation for diffusion cost. I think this is explained well in voids or defects chapter, right? This is just a probabilistic function. Your diffusion will include, how it includes all of these things is, this is being taken care by probabilities. Okay. Suppose if there is some void, if some x needs to come to here, there should be separation like this. There will be vibrating like this. There should be separation. During that separation only, this will come out quickly. Because when they are bonded tightly together, it can't come, right? There will be vibrations as the temperature increases. When this and this moves away from each other, the atom will move like this, and that is how it gets diffused. That probability is nothing but this one. Okay. So what is the value you get? Q. So you get 87.6 kilojoule per mole. Very good. Please do this question. It's a very good question.
Hello, sir. Can you explain once the previous questions?
Okay. So consider a random variable x with what is given that takes values +1 and -1 are with probability 0.5 each. The values of cumulative distribution of the function at x equal to 1 and x equal to -1. So when you take x equal to -1, you will be taking all the values previous to 1, which is x less than or equal to -1. Right? So this function will be like this, suppose. Cumulative distribution function. If this is x, this is 1. This is x equal to 1. Right? He's saying the function, the probability of each at this values takes values 0.5, 0.5. The values of cumulative distribution. This whole function is again, sum of all the probabilities is 1 again. Okay? When you take the value which is exactly x equal to -1, this part is being divided into -1 and +1. Okay? When you have x less than or equal to -1, it means he is considering all the values from the probability 0 to 1. Because see, what happens in a cumulative distribution function is the probability random variable x. You will be having this cumulative distribution function can be written as p of whatever value you take less than or equal to -1. When you consider this, you are considering only the maximum value itself. It will take away all the values already. So when this is 0.5, this is 0.5. When you take this x less than or equal to 1, x less than or equal to -1, you have only value which is -1. But here you have value less than 1, +1 and -1. So both the values will be included here. This means the whole function, this means only half of the curve. So you are having 0.5 and 0.1. That's all.
Clear.
Do you want me to explain mechanical metallurgy question? Okay. There is nothing here to explain actually. See, this is you have all the strains like this sigma 1, sigma 2, sigma x, sigma y, tau xy, tau yx. These are all graphs which are there. Huh? You are taking, you are writing the principal functions, principal stresses, principal shear stress, principal stress in terms of all the stresses which are given in direction. Sigma x plus sigma y. You don't have any sigma z direction. So you write sigma x plus sigma y, sigma x minus sigma y by 2 cos theta plus. This you can derive actually. I think in the first 2D stresses itself, we'll be deriving this, right? One stress is like this, one stress is like this, and one stress will be like this. Right? These two, when they act like this and like this, these two will be resolved. You will be considering Sy, Sx, sigma x, sigma y. If you resolve all these stresses, you will get this equation. That is what I have written direct equation itself here. You can derive, but derivation itself will take like 10 minutes. Okay? So you'll get principal stresses sigma 1 can be written in the form of sigma x plus sigma y. This you can write as plus or minus, or you'll write sigma max and sigma min is equal to sigma x plus sigma y by 2 plus or minus root over sigma x minus sigma y by 2 whole square plus tau xy square. Like this you'll write now. Just previous to this one will be there. These are maximum and minimum. These are at any angle. That's all. So you put all the values which are given in this, you will get these values. Understood, Devasri? Those derivations, you practice it on your own. Here, we can't do all these derivations. If time permits, we'll do next time. For now, you understand that 2x 2D curve, practice it in that way. Don't try to remember the formulas. So refractories, the refractories used in stack region have high abrasion, should have high abrasion resistance. That is for sure, because they'll fall down, right? Carbon graphite blocks are used for the construction of upper stack regions. No, you won't be using, because carbon disintegration takes place in the upper stack region. There itself you will be forming CO gas, right? So there you can't use carbon or graphite blocks there. So this can't be used here. This is true. So it is A is true, B is false. Generally, you'll be using high alumina bricks you'll be using. See, whatever fly dust you'll be getting, right? Fly dust, fire ash, or fly dust you'll be saying. Those dust will be collected, they will be compacted along with alumina, they will be made as refractory bricks. Okay. Not directly, I mean, they'll undergo a few processes also. What is the assumptions made by Clausius Capron in 1850? Molar volume of liquid is negligible compared to gas. This is true. Vapor of an ideal gas, the liquid, vapor of ideal gas, the liquid is also in equilibrium with the solid. Vapor is an ideal gas. The liquid is also in equilibrium with solid. Vapor is not a real gas. You'll consider it as ideal gas according to Clausius Capron, right? So both are correct. It's not a real gas. In roasting, the set of conditions that favor sulfide formation from metal sulfide concentrates are. Okay, it's a very good question. So sulfur, you need to convert with high roasting, you'll be converting into SO2. For this formation, metal sulfides you'll get from metal sulfide, that is ZNS. Concentrates favor sulfate formation. You will be getting ZNO first. This will be converted into ZnSO4, like a medium, electrolyte medium. So you need high temperature, high partial pressure of oxygen. You need more oxygen to completely convert it to zinc oxide, which is calcium. For this, you need high temperature also, not partial pressure of SO3. Oh, okay, sorry. You need high temperature, but from ZnSO4 formation, you don't require high temperature. For ZNS to convert into ZNO, you need high temperatures. So for ZNS formation, because he's asking only sulfate formation from metal sulfide. So you want directly from this. So it is partial pressure of Zn SO3 is required and O2 is also required. So this step is eliminated. Directly you are getting ZnSO4. Means what? SO2 is being converted into SO3. This is there. And ZNS is being converted into ZNO. These two are being taken care. So from high partial pressure of oxygen and high sulfate pressure, SO3 pressure. Okay. Consider the alloy 1 and 2 match the expected A, B, C, D, E stoichiometric ratios. Why not? So someone is asking a question, right? Why not excess air? You're taking excess air itself. That is why high partial pressure of air. Excess air is in fact making the roasting possible. But generally, what I mean is when you take excess air, that is reacting with more presence of oxygen only. Remaining air will go out. Okay. If you do roasting, B and D are options. Excess air, okay, it's a good question actually. Excess air you consider O2 plus N2, no? O2 plus N2. You doesn't mean directly O2 plus N2 here. In roasting, what generally happens, I'll tell you. See, you have blast furnace, you have roaster. Blast furnace, C is there, O2 plus N2 will react, you will get CO or CO2, and N2 will go unreacted. This is good. But sulfur has high affinity towards oxygen, carbon also has high affinity towards oxygen. Nothing, N2 is doing nothing to this gas. But here, what will happen is, you want a fluidized bed to be formed here. Right? In ZNS roaster, what is there? You'll put the ore powder like this. You'll put the ore powder like this. And you want this to be separated into lighter particles like this. This is the fluidized bed you get. So each of the ZNS will be reacted with oxygen. You can use N2 also, but partial pressure of oxygen, if it is high, your roasting will be very good. That is what it is. Here in blast furnace also, you'll try to increase the oxygen content. You'll enrich with oxygen. No, your blast is also enriched with oxygen sometimes, but it is of higher cost. In case of sulfur formation, you'll get SO3. This will be converted into H2SO4, ZnSO4. This you are converting into leaching. So you are using some pure pressure, pure oxygens here. In blast furnace, you don't require any of those. You are getting gas which is CO2. This you can't convert into anything. Here SO3 is being converted into sulfuric acid, but CO2 is not being converted into anything. So better to use excess air, hot blast air. But in roasting, you'll be using this kind of. Okay. Pure oxygen is better off. Alloy 1 and 2 match expected phases A, B, C, D, E. So A is liquid generally. So this will be A is B dash. Okay. Next you have B. B is again liquid only. Liquid, some fraction of this also will be there. So you have B as C. This one. You have some amount of proetetic alpha also. This is C dash. You have C. Oh, the answer is directly given here. Okay. So next you have C, which is what? Next, C you have what? C you have solid plus liquid again. Solid plus liquid is D dash. Then D. D is again solid, complete solids, right? Where is complete solids? You have eutectic alpha and eutectic beta. You'll have E dash. And E is completely a lamellar structure. No, eutectic phase, right? Sorry, not eutectic. What do you call? This is completely perlite structure. A whole austenite is being converted into perlite. So your 100% perlite will be lamellar structure, which is A dash. A polycrystalline material with an average grain diameter of 36 microns has a yield strength of 300 MPa. The yield strength for the same average grain diameter is 9 microns. Sigma naught is 100 MPa. Okay. K by root D. So what do you have here? So I have a yield strength of 300. Here he is asking an yield strength of other thing. He gave sigma naught as 100. So you have again sigma minus 100 is equal to root over D2 by D1. So what is your D2? He's having average diameter of this is 9, this is 36. So it is 3 by 6, 1 by 2. So now 400 equal to sigma naught minus 100. I mean sigma. So your sigma required is 500 MPa. Yield strength is 500 MPa. Okay, very easy question. Next question. A sandwich composite made up of aluminum sheets and polyethylene foam core. If it is isostress, Young's modulus is 1.2 GPa. The approximate volume fraction. Isostress is what? What is isostress and isostrain? What? So strain will be equally distributed on all the fibers. That is isostrain. So this is iso stress. This is isostrain. So you have 1 by E is equal to Vf by Ef plus Ec. You have Vm by Em. So you have 1 by 1.2. 1.2 into 10 power 9, you can take 1.2 gigapascals. What is this? Fraction you don't know. What fraction do you want to find? Fraction of foam. Polyethylene foam core. So aluminum sheets is the matrix. So foam is a fiber. So fiber you take it as x by fiber you have what 600 MPa plus. If you don't know what is fiber, what is matrix, you can see the values here. Polyethylene 600 more reinforcement will have more Young's modulus, right? So plus 1 minus x by 70. So please solve this. What will you get? 1 by 2. Oh, this is given as MPa. Oh, so this is 0.6. This is smaller one actually. Equally distributed. These polythenes are your fibers. So please solve this. You can take this as 10x by 6 is 5 by 3x minus x by 70. 1 by 70, if you send this side, you'll get 5 by 6 minus 1 by 70. Please solve this. X, you are getting what? X into 5 by 3 or 5 by 70. So it is 350 minus 3 by 10. 45. Oh, 5 by 3 minus 1 by 35. So it is 35 fives 75 minus 3. So 1 by 2 into 175 minus 3, 172 by 3 into 35. Very good. So 352, 352, 35 table, you get uh, 6. 6 again, this will get cancelled. So you get x equal to 172 by 347. 75 double is 350, right? So it is nearly 0.5. So you get value as 0.5. Is asking volume fraction in percentage. So it is 50 percentage. A coin is tossed. The probability of getting head is p less than 0 less than, okay, p is between 0 to 1. N be a random variable denoting the number of tosses till the first head appears, including the toss where head appears. Assuming successive tosses are independent, the expected value of n is. Okay, it's a good question. So he is asking the probability of getting head is p. Now let n be the random variable, the expected value of n, denoting the tosses till first head appears. Please try to solve this. So n be the random variable denoting the number of processes till first head appears. Did anyone solve this? What, no one done this? Okay, let me tell. So you have probability, suppose it appears such a way, you need till first head occurs, right? So how will the probability be? So your expected value n is equal to sigma of k into 1 minus p whole power k minus 1 into. What does this mean? Suppose first time itself the head has appeared. Okay, first time itself the head has appeared. So it will be P. Suppose second time 1 minus P into P. Right? It is 2C1 into this. 1 minus 2 into 1 minus 1. Next time it is 3 into 1 minus p into 1 minus p into p plus so on. What will you get here? Sum of all this. Or else you can take like this. Suppose if you didn't understand this, I'll explain you in a simpler way. Suppose you have first toss p. First toss you didn't get p. Next toss you got it. 1 minus p into 1 minus p into p plus 1 minus p into 1 minus p into 1 minus p into p. You go like this. So this is E. It will go till infinite, right? So this I can write as 1 minus p if I take common. I'll get p plus 1 minus p into p plus 1 minus p into 1 minus p into p. So on again till infinite. So I can write this as p plus 1 minus p into E is equal to E. So I can write E into 1 plus p is equal to P plus E. Oh, so I need to change like this. So it is E into 1 minus. Did I do anything now? Okay, if I take P common. Oh, everywhere I'm taking P common. Oh, sorry. So 1 minus P if I take. So P plus 1 minus P into P plus so on till infinite. This is again E. Is it right? So what do you get? So 1 plus E, which you get P into E into, sorry. E is equal to P plus 1 minus P plus 1 minus P into E. So your P is getting cancelled. Your EP is equal to 1. PE is equal to 1 by P. 1 by P. So overall probability is 1 by P. Please do this question. Volume of blast per ton of hot metal was found to be volume of blast per ton of hot metal was found to be 2868 meter cube. The go Qs per ton hot metal was 900 kg. Okay, he is given 2868 meter cube. In this, oxygen is only 0.21. So you get 602 meter cube of oxygen. So you require 24 kg. 24 kg generally for 24 kg carbon you require, because C plus O2, right? CO2. So this is 12 kg requires how much? 22.4 liters. So you get 24 kg requires 22.4 liters of oxygen of O2. Then you already have 602 meter cube. How much is the weight of oxygen? So you require 645.3 kg of oxygen. So how much is already present? Only 88%. So your blast furnace requirement is what? 645.3 by 900 into 0.88 into 100. What is this value? Carbon coke rate. So what is the coke you are using, and how much your coke you are putting? So totally it will be 81.5%. Their answer is 81.5%. The surface is at 200 degrees centigrade and it is exposed to surrounding at 60 degrees centigrade and convects and radiates heat to the surroundings. The convection coefficient is 80 watt per meter Kelvin. The radiation factor is 1. If heat is conducted to the surface through a solid of conductivity 12 watt per meter, determine the temperature gradient. So you have heat conducted is equal to heat radiated plus heat convected, right? So you have minus k into dt by dx equal to h into delta t plus sigma into t1 power 4 minus t2 power 4. Any same kind of temperature flow will be in the same way, right? Okay. Now what do you have? So I have 80 into 200 minus 60 plus sigma is what? 5.67 into 10 power minus 8 into 473 power 4 minus 273 plus 60, 333. 333 power 4 is equal to minus 12 into dt by dx. He's asking what is dt by dx. The dt by dx equal to, this is what nearly minus of 11,200 plus 2140.9 by 12. So you get minus 1111 degree centigrade per meter. So it is A. Someone has asked one question I didn't see. You can find martensite in other phases also. Martensite is, see, martensite is just started with the name in steels actually, but martensite is a name given to the phase. Okay, hard phase which is found to diffusionless tear formations. This is name given to the phase, not actually to the steel itself. Okay. Some of the features of surface hardening by laser beam is produces little distortion, because surface hardening produces little distortion, induces compressor reduces stresses on the no laser does. Next, which property combination is most ideally suited for armor? For armor you need high strength and high toughness, nothing else you can see. High strength, high toughness, that's all. Wire drawing usually starts with a coil of hot rolled rod, which is first cleaned by pickling. Yeah, this is true. Next, heat generation is major. See, wire drawing with a coil is hot rolled rod, whatever is there. You will first clean it with pickling. Pickling is nothing but acid pickling or anything. You just put in the liquid such a way your surface gets removed and it is cleaned again. Heat generation is major concern in drawing operation, right? Heat generation is a major concern in drawing operation. So partial heat is removed by interpass cooling. This is also right. So both are true. They're very much needed while wire drawing processes. At 2000 Kelvin, it is known enthalpy of a reaction is minus 26176 kilojoule per mole. Okay. So you have K is equal to, so you have K is equal to 0.002. Oh, equilibrium of a reaction, about 300. So you have K1 by K2 is equal to exponential minus Q by R into 1 by T1 minus 1 by T2. That's all. You put in this and solve the equation. So what is your K1? Initially at 2000 Kelvin, it is 0.2209 by K2. You need to find exponential minus heat is given delta H by R minus 2.6 into 10 power 7 by 8.314 per kilomole is that a Kelvin. Enthalpy of a reaction is given per kilomole. So then into 10 power 3 is also there. So into 1 by T1 minus 1 by T2, which is 1 by 2000 minus 1 by 3000. So this 1000 is also there. This 1000, this you get 10. So you have 0.2209 by K2 is equal to exponential minus 26 by 25 by 3. 1 by 2 minus 1 by 3. It is nothing but 1 by 6. So into 3, 2, 13. 13 is nearly 0.5. So it is 0.22. K2 is nothing but 0.22 into exponential 0.5. So e power by 2, 1 by 3. Okay. So 13 by 2. So what do you get here? Oh, you're not getting this one. K at 2000 is given as this one. K1 by K2 is nothing but 1 by T1 minus T2. 1 by 2000 minus 1 by 3000. 1 by 6, 13.6. E power 0.5. So what is the value you're getting? Anyone? Answer in the chat. Oh, enthalpy of the reaction itself is given positive. So Q is given as minus 26.176 megajoule per kilomole. So it is again positive. So you get minus. So K2 is exponential minus 0.5 into 0.22, which is 0.592. Oh, sorry. This is 0.592 into this one is 0.131. Okay. The temperature ratio Ts minus T is equal to Ts minus T infinite equal to Y by 0.0075. K is equal to 0.03. Determine the value of K. So H is equal to minus K into dou T by dou Y. Y equal to 0 by Ts minus T infinite. So this is your H. So you get dou into Ts minus T by Ts minus T infinite by dou Y is equal to minus 1 by Ts minus T infinite into dou T by dou Y. From here you got it. This is equal to 1 by 0.0075. So you get H is equal to minus 0.03 into Ts minus T infinite by dou T by dou Y. Ts minus T infinite by 0.0075 by Ts minus T infinite. Again, Ts minus T infinite gets cancelled. You get minus minus. Again, this is also minus minus gets cancelled. You get 0.03 by 0.0075. So your H will be how much? Too much. 4. A cylindrical wire is given of 3 mm is diameter required to carry a current of 12 ampere with a minimum 0.01 volt drop per foot, 300 mm of wire. Which of the following metals and alloys listed in the table are possible? Okay, it is given. You have conductivity sigma is equal to what is it given? A cylindrical wire 3 mm 0.12 inch dia is required to carry a current of this much. Voltage is given per foot, which is 300 mm of the wire. The conductivity is nothing but by VA. You have 12 ampere into 300 into 10 power minus 3 meters by number of electrons which are being carried by 0.01 into pi into pi d square, right? Pi d square is 1.5 into 10 power minus 3 square. Then sigma is 5.1 into 10 power 7 ohm meter inverse. So this you need to understand. Greater than this values only you can take it. So which are having greater than this 5.1 greater than this is gold, copper and silver only you have it. Even gold is having less than that. So answer is only copper and silver. What is the maximum stress developed in the material with an internal crack subjected to external stress of 120, 200 MPa? So you have sigma m is equal to internal crack subject to an external stress with a crack tip radius. Whenever you have crack tip radius, you need to get sigma m is equal to 2 sigma naught root over a by rho. So this is 2 into 200 into root over. What is your A? Internal crack length, which is 1.7 micrometer by 0.01 radius. So it is 5215 ampere. This is a standard question from the textbook, very important standard formula. So you have a liquid phase silicon nickel composite has a solid grain boundaries. So these are your solid grain boundaries. This is how your solid grain boundary will be. You'll have this grain boundary like this, like this. So you have angle theta by 2. So what is it saying? So you need to understand your sigma SiC and nickel is surface which is 0.45. Sigma SiC is 0.8. Your radius is, gamma, sorry, 20 by 2 is equal to 10 micrometer. So gamma SiC nickel cos theta by 2 plus gamma SiC nickel cos theta by 2 is equal to gamma SiC. So you have 2 gamma AB cos theta by 2 is equal to gamma. Now what do you have? Cos theta by 2 is equal to gamma AA. What is gamma AA? Which is the interfacial energy of 0.8 by 2 into 0.45. So theta by 2 equal to cos inverse 8 by 9. Theta is equal to 54.53. Okay. So he's asking what is the average interparticle neck size. You know sin theta by 2 is equal to AB by OA. So AB is already given 4.58 micrometer. So neck size is 2AB. Nearly 9 you can take. So in nanometers it is 9.16. So which of the following? So the following will enhance fracture resistance of the steel. Grain refinement will increase. Increasing sulfur content will make material brittle. Increasing manganese content will decrease sulfur content. Again, cauterization will also increase surface hardness. A 0.5 meter cube cylinder contains nitrogen gas at 600 kPa and 300 Kelvin. Now the gas is compressed isothermally to a volume of 0.1 meter cube. The work done on the gas during this compression process is. So you have V1 is equal to 0.5 meter cube, V2 is equal to 0.1 meter cube, T is equal to 600 kilopascals, T is equal to 300 Kelvin. So what do we want here? So P1, V1 is given as 600,000 into zero point 0.5, which is 300 kilojoule. You have nRT. You know, work done by the gas is nRT ln V2 by V1. So nRT is nothing but 300 into 1000 into ln 2, which is 483 kilojoule. Is asking work done on the gas. Work done by the gas is negative here, whatever you got. Oh, this is 0.2. Sorry. Work done on the gas, work done by the gas. So 483. The Miller indices of the plane whose intercepts are A by 2, B and 2C. You have intercepts 1 by 2, 1, 2. So reciprocal of intercepts will be 1, 2, comma, 2, comma, 1 by 2. If you make this into integers, it will be 4 to 1. So your plane will be 4 to 1. The charge in Coulomb is dash into 100 required to reduce 1 mole of Fe plus 3 ion to Fe. So you have Fe plus 3 to convert into Fe, you require 3 moles of electrons. So 1 mole of electron is nothing but contains 1 Faraday, which is 96,500 coulombs. So 3 Faraday is 3 into 96,500. So it is 28,289,500 coulombs. Into 100 is asked. So it is 2895. This is a basic question. Simpson's 3/8 rule is for third order fitting polynomial. Trapezoidal rule is for first order fitting. Simpson's 1/3 rule is for second order fitting. So answer is 3, 1, 2. Four red balls, four green balls, four blue balls are put in a box. So you have 3 balls are pulled out of the box at random, one after another, without replacement. The probability that all the 3 balls is red is 1 by p. What is the value of p? Okay. So I have 3 balls are taken are red. So I have, if I take how many balls are pulled at random? 3 balls are pulled. I am taking all red balls of 4C3. All are from red balls itself. And each are taken one after other without replacement. Next you have, out of all the boxes, you can take 12C3. This probability is how much? Oh, sorry. Here he is saying, first 4 is taken 4C1. Next it is 3C1. Next it is 2C1. So all are from that itself. Next here it is 12, 4 plus 4 plus 4, right? 12C1, 11C1, 10C1. So this is the probability. So what do you have? 24 by 12 into 11 into 10. 24 is 2, 5. So it is 1 by 55. So your P is 55. Okay. This P and this P is different. This is probability P. This is small p. So small p is 55. And your question number is also 55. That's all. That's all for today. You can leave.